So today we're completing the penultimate, almost the final step of our intro to object-oriented programming journey. We're going to talk about inheritance, which is probably the major concept in object-oriented programming after classes. Getters and setters are important. You're going to see them on the assessment Friday. Class methods, class attributes, static methods are important and touch on important concepts. You don't use them as much. Inheritance is really important. You use it sometimes, but you don't want to use it too much because it's very powerful. So we're going to learn what inheritance is and how to use it, how inheritance helps us write flexible code, when to use inheritance, when not to. What inheritance is. And we're also going to touch on one of those 4 pillars of object-oriented programming, polymorphism, and we're going to see using polymorphism with inherited methods. So we're going to cover, I think, a lot of good ground today, and I'll fill this out a bit and do a bit of talking as we kind of go into our initial slide deck, and then we will be writing code. And I'd say this is, after the first day of OOP, this is probably the most important one. Getters and setters are important. You don't need them all the time. Again, class methods, class attributes, important, not used as often. Inheritance, really, really core. And I think we've been set up, and I think you'll find that it's pretty cool. So let's talk about inheritance. And the part 2 of the lecture after our work time will be about polymorphism. So inheritance is where you can create a class, say an animal class, and then you create maybe a dog class, and the dog can inherit everything from the animal class. And if you make a cat class, the cat can inherit everything from the animal class as well. This is referred to as child and parent relationships, where the animal would be the parent class and the child inherits from the parent, right? So like cat would inherit from animal, dog would inherit from animal. We're going to see a special method called super that is one of the mechanisms of inheritance. And we'll talk a little bit about instance versus class methods with inheritance. Multiple inheritance, where maybe there's an animal and a mammal class that dog inherits from both. That is less common, but it is good to see. And then we'll, towards the end of the lecture, talk about when to use inheritance and why, versus another sort of design pattern called composition. Multiple inheritance, I don't think is actually on the weekend assessment, but everything else is. Everything we've covered here is on the assessment. We will give you pretty clear guidelines on what to build. Your task will be to read tests and how to build it. Tomorrow afternoon, Francisco is going to lead an OOP review where he is going to build a project similar to the assessment project, end to end, that will be covering everything we learned. So that's going to be really useful and a really good time to dig in and ask questions. If folks have any questions about the agenda for today's lesson before we dive in? Cool. So, the basic idea, I think, is simple, right? Like a child stereotypically inherits the qualities of their parents. We'll see how to write this code in a minute. But the basic idea is I can write a phone class and every phone should be able to make a call. So maybe that's an instance method. And every phone maybe should be able to answer a call. And every phone has a phone number. And maybe that's an instance attribute. And then if I create an iPhone class that inherits from phone, I get all those things from phone. And if I make a candy bar Nokia phone class, it gets those. If I make a flip phone, it gets those. And I can have consistency. Polymorphism we'll talk about later, but the idea is different ways of doing the same thing. Different ways of doing the same thing. And if we go back to the phone example, for an iPhone, you know, you can make a call, right? You can dial. For a flip phone, you can make a call. And I'm kind of writing terrible text here on purpose just to kind of draw your guys' attention to this. For this phone, the candy bar phone, you can make a call. And so you could imagine that we would have a method named call, an instance method for all of these phones. But under the hood, what each of those does might actually be very different because these are different kinds of phones. The iPhone in particular is pretty fancy. So polymorphism, like many ways of doing the same thing. And in fact, if we, let's get rid of our calls. If we just look up the term, treating different forms of an object as if they were the same. I just want the plain old definition. So let's look up that. Occurring in several different forms. Occurring in several different forms, right? So I might have a call method on different phone classes and the name is the same, but they all work in different ways. So we'll see polymorphism more in the second part of the lecture, but just to kind of warm you guys up and start talking about the concept. But now let's start writing some code. Let's see inheritance in action. And let me go ahead and create some code here. I do not want to update my CSH right now. So let's make some simple classes. Let's make some animals, and then we'll talk about the problem that inheritance helps solve. So let's say we have a dog class, and these are both going to be very simple. I'm not going to be adding getters or setters, or really class methods or attributes right now, just because I want us to be able to look at some simple class examples as we discuss inheritance. So our dog has a name and a breed. Our cat has a name and a color. Maybe our dog has an instance method, bark. Maybe we've decided for whatever reason, let me give us a little more real estate here. I may have to bump the font size down in a bit. And we've decided the cat has a different method named make sound. So this works, but it doesn't do a great job of things. If we have more animals, we start having more repeated code. If I have a parakeet, this name attribute gets repeated. If I want common methods for consistency with names, that becomes harder. And if we also want maybe to have some other common properties that all animals have, we end up with more and more repeated code. So the solution here is to write an animal class that both cat and dog inherit from. And let me go ahead and get a little room. Let's do that up here. So this is going to be our parent class. And can everyone see the screen okay? And does the split work okay in terms of seeing stuff? Awesome. A parent class, you write it just like any other normal class. And for animal, every animal is going to have a name and every animal is going to have a species. And if I wanted to, I could totally, like we've been doing in the course, instantiate a new parakeet object, a new instance of the animal class. And I might as well give the animal a dunder repr method as well. So that we can see some information about it. So that when I can just print out Polly the parakeet. And if I run my code now, this should all be pretty familiar to us. And let me just shift the zoom grid over a bit, folks. There we go. So the animal class is a normal class like all the ones that we've been making. But we're going to use it in a different way. It's a normal class like all the ones that we've been making, but we're going to use it in a different way. So animals all the way up there. Down here is cat and dog. Let's start with the dog. Let's have our dog inherit from the animal class. And so this is how you do inheritance. This is the core step, and it's pretty simple, as you can see. Dog is now inheriting from the animal class. Let me go ahead and let's make a dog. Let's make Daryl. And Daryl will be a golden retriever, or actually a golden doodle. And let's print Daryl and see what happens. So a couple things have happened here. The first thing is obviously we have an error. If we look at this error, we see dog object has no attribute species. And it's happening. And I noticed that I didn't even write a dunder repr method for Daryl the dog, for the dog class. The dog class inherits the attributes and the methods of the parent class. And this error is happening because the parent class's repr method gets called here on line 41 when we try to print out Daryl. And we're going to learn in a minute how to pass in species so that our dog inherits the animal class and we're going to set the species. But right here, we can see this happening. And to kind of drive this home a bit further, let me just add a print statement here that just says animal class repr. And let's just, and let me just do that there just to kind of provide further proof And so we can run this without error. Oh, and I forgot I need to have, the dunder repr always needs to return a string, not print something, which is always my gotcha. And so we see right here, and let me just go ahead and I'll just, I think, add something to the print statement and make it an F string. Printing Daryl the dog. And so we see that Daryl is using the animal class's dunder repr method. And this is true of any method that I add on here. It doesn't have to be a dunder method. It could be all animals need to eat, right? So maybe let's do print we'll use names in a minute. And if I bump the font size back one, is this still readable to people? Okay, awesome. I know for one or two folks, the bigger font size is better. There's just not enough screen real estate. I'm gonna be constantly scrolling, so I think I have to make the switch. So if I run this now, our dog, Daryl, there's no eat method. The eat instance method, right? This is not a class method. This is for an instance of the animal class, a particular object, belongs to the animal class, but the child class, dog, inherits from the parent. It inherits everything from the parent. And so there we see Daryl eating. Let me just pause and check in and see what questions folks have or things that people might be curious about. How are we feeling thus far? Okay, awesome. Sounds good. I'm seeing a bunch of nods. So I think the next natural question is, well, like this animal class takes in arguments in its constructor and its dunder init method, the animal name and the species. How does that work? Like when we create Daryl the dog, if I over here, if I change this to be Daryl eats, and if I change this to be I'm an animal named self.name, is this going to work? Let's see. So this actually works great. This is kind of cool. It sure seems like what's happening here is because name here is the same name, the attribute, the instance attribute name is the same. This seems to be working, right? If I change this to animal name and I change this to animal name and I change this to animal name, then we run into an error where we see dog has no attribute animal name, right? The dog object is trying to run these methods, but has no animal name. So, and we would run into this same problem with species, right? If I do my species is we see dog object has no attribute species. So the child class inherits from the parent and inherits the methods, but this parent dunder init method hasn't been called. Daryl the dog doesn't have a species attribute. And in fact, every object in Python has a special dictionary, a Python dictionary named dunder dict, _dict. We could in fact even print out one for the dog class itself. And this will show us all of the attributes this object has. And it's this first line up here. Let me comment out the others so we don't get the error. So this dictionary under the hood, when you create an object, an instance of a class, Python creates this dictionary that's an attribute on that object named dunderdict, and that's where it has the names of all the attributes on there. You can also use a command called dir that shows all the attributes of an object. I think it will also show method names as well. Yeah, you can see dir gives us way more information. There's dict over there, the dictionary. Here's those instance method names, bark, instance attributes, breed, eat. Note that our dog object has inherited eat from the parent. It's inherited that method. Oh, and I see some questions in the Zoom chat about importing and a good comment about best practice. Yes, best practice is to have each class in its own file. You know, if I had like 3 animal classes and they were each 3 lines, I might keep them all in one, but if it starts to get bigger, I would break them up. I just for simplicity, I was just doing it all in one file and I just split to have 2 views of the same file. If it makes more sense, I can make a runner py. And actually, why don't I do that now just for us to see? So I think I'm going to keep this right now because I like having the parent class on the right and the child on the left. But yeah, and we would need to import if we had these in multiple files. Does that make sense? And do folks have any questions around that piece? Do you all want me to make a runner py or does this work okay? Okay, I'm taking the silence as an affirmation that this works well. Cool. And let me check in and see what questions people have about inheritance thus far. And also about this dunderdict and dir function that we're seeing to see this Daryl object in a clearer light. How are people feeling and do folks have any questions on their minds? Oh, and yes, sir.
Could we so like rather than using the super method for instantiating the species of the dog, or maybe that's what we'll have to do anyways, could we write like a if statement in the animal, like if instantiated by dog, species equals dog, or self.species equals dog?
It's a good question.
Or would that be kind of a little overload? Is there going to be?
Yeah, I'm not sure if there's a way to do it that way. If there was, I'm not sure that we would want to.
That answers my question. Thank you.
Yeah, totally. Yeah, good question. And yeah, we're gonna see the super method in just a moment, which is gonna, as you mentioned, that's gonna show us exactly how to set the species argument. What other questions do folks have? What are people curious about that might be good to go over? Okay, let's see how to use the animal species. So the missing piece here, because this error that we're seeing, right? When I print the dog with the repr statement, we get an error. And the error is dog object has no attribute species. So the parent class has this attribute that gets passed in the dunder init method species, but the child does not. So we need to figure out a way to set this. And this also tells us that when we instantiate a dog, we're not actually calling this dunder init over here from the parent. And sometimes we want to. And let me add a print statement here just for fun, just to prove it. And let's do one that should work. So we ran Daryl.eat. We created Daryl the dog. At no point did I see this print statement on line 4 that's my tracer bullet to tell me that this parent class dunder init method was run. Sometimes we don't need to run the parent dunder init method, but most of the time if we're inheriting, we do. Most of the time we want to. And to do that, we need to use a special keyword named super. And this is actually, well, I guess it's a class, but we call it like a function. What it does, this VS Code description is not very helpful. This returns the parent class. So I think this will work doing it this way. We're actually going to write the code a different way, but I think this will work. Let's make sure this works. Yeah. So no, now we see that print statement, animal.init. Super returns the parent class. Right? So what we're doing here basically is animal.init name species dog, which by the way is the exact same thing as doing this when we like create an animal the normal way. And in fact, I don't even think we need species equals dog here. I think we can just say dog as the second argument. Let's make sure that that works. Yeah. Yeah, because it's not a keyword argument, and we're not passing in species here, because whenever I create a dog, their species is always just going to be dog. So we like, I wouldn't want to, make Fido like this, dog dot init. But I could. This actually works just fine. We just don't normally write it that way. And it does the same thing as line 50 here. So super returns the parent class, and then we can call the dunder init method on it and pass in whatever arguments are needed. We could also get attributes from the parent class if we needed to. And so now let's go ahead, let's print out our Daryl information. And let's print out Daryl the dog and see if that repr statement works. So first off, this dir Daryl statement prints out a ton of stuff. Let's actually use this one because this one's going to have a bit less. There we go. So note that this special dictionary that holds all the instance attributes of this object, Daryl the dog, now has species when it did not before. Note that this print statement that triggers the animal class's dunder repr method now works fine with species because our Daryl the dog object has a species. Note that we see the dunder init method from the animal class has been called, and that's because we used super to get the parent class and call the dunder init method on it. You usually see that written like this. So let me just, in fact, comment that stuff out. And let's just do super. Because this is method chaining. This returns animal, and then we call the dunder init method on it. But you usually see this written in just one line like this, unless you need to do other stuff with the parent class. So this is a good pause point because I've been doing a lot of talking, and this is super, and using this mechanism with inheritance is sort of one of the big concepts for today. So I just want to check in and see what questions folks have and what's on people's minds. One, yes, sir.
So we have to call the super dot init, like we have to specify that it's the init method. We can't just pass it similar to how we just do down there dog and then put in the parentheses because we're inheriting. So we have to like specify it because of that.
Yes, that's correct. And in fact, if we hover over here, we can see that VS Code figures out that this is the dunder init method for the animal class. You can see name and species. Yeah, like if I had a class attribute, say, on the animal class, and maybe I wanted to like access that somewhere in here, I could do, parent class attribute who it might not like me calling super twice, so let's comment this out for a second, do it this way. So you don't always need, you usually don't need to do that, but super returns the parent class. This is the same as animal.food, right? So sometimes maybe we need a class attribute or a class method. So that's why super's job is to return the parent class. And then it's our job to tell Python if we want to use the parent class's dunder init method. Does that make sense?
Yes, thank you.
Yeah, totally. James, yes, sir.
Sorry if I missed this before. Is there any difference when you use super dot init versus animal dot init? Are those doing the same thing, line 44 and line 41?
Good question. If dog was inheriting from a different class, super would get us the dunder init method for the canine class. With animal, it's hard coded. So that's the difference, right? This gives us way more flexibility using super to do it that way. Because I don't want to have to hard code that, because what if the class name changes? What if I decide to do it differently? And also later we'll see there's like, you can do multiple levels of inheritance, though you generally want to avoid it. Does that make sense? Yeah, great question.
Yes.
Yeah, you're absolutely right that that would work, but that's why you don't want to do it. Yeah, great questions. Sean, yes, sir.
So if you have the self.name in your parent class animal, why do you still need it in the dog class?
Yeah, that is a great point. And actually, we don't. That is a very good point. We need it in as an argument in the dunder init method for the dog, so down here on line 55, when I create Daryl the dog, I can pass in his name in the constructor, here where we call the dunder init method on line 55. Because I don't want to create an animal object directly. I want dog to inherit animal, and then I want to make dogs. So we need name here, but you're absolutely right. I don't think we need it here because we have it here already. And this should work just fine. Yeah, excellent point. That's a great refactor. Refactoring is the term for where you don't change the behavior of what your program does, but you change the guts of how it works, where you change the code. And now that we have inheritance, the dog class doesn't need a name. Yeah, awesome. What other
Thank you.
questions do folks have? Totally. And did that make sense?
Yes.
Cool. Yeah, great point. Great point. What other questions do folks have, or things that we're curious about? Because this is good, because we're digging into all the right things here. Ryan, yes, sir.
So I noticed when you did the super init, and then you clarified the species, from there so that the class animal would know that Daryl is a dog. When you initially made Daryl, it just has his breed. So is that basically making it so that everything in the class dog, it will know to make the species dog for the animal class?
Exactly.
Okay. Cool.
Yeah, you
Thank
hit the nail on the head. Exactly. When Python runs this code, it reads all the class definitions. It gets down to line 55. It sees, oh, I need to call dunder init for the dog class, the dunder init method, and pass in these two arguments, Daryl and Golden Doodle. So then the flow of execution, I'm not going to bust out the debugger now in the interest of time, but that would be the best way to do it. The flow of execution jumps up here to line 39. Daryl gets passed in as a variable name that gets created, that will be deleted once dunder init is done. Breed gets passed in as a variable name. We get down to line 41. Python says, oh, super, let me find the parent class of this class and return it. And the parent class is animal. Python sees this and it says, oh, we've got the dot notation on the object. It wants me to call the dunder init method on the animal class and pass in these two arguments, name, Daryl, and we've hard-coded dog in here, like you said, for exactly the reason that you said, so that now every time we create a dog, it's of the same species. And let's go ahead, in fact, and did that make sense?
Yes, thank you.
Yeah, totally. And you folks have probably figured it out, but my sort of default check-in question is, did that make sense? Because sometimes I don't know if I'm over explaining or going too in depth on stuff, because I've been doing this too long, so I don't always know if I'm doing it. So it's an honest question. This is a good transition point to using inheritance with our cat class. And let's see what this looks like. And does someone want to maybe get me started on how we might modify the cat class to inherit from animal? Jacob, yes, sir.
Okay, so you are gonna have to change where it says class animal, and you're gonna put in our class cat, and you're gonna have to put in parentheses animal.
Yep.
And then, you can probably get rid of self.name equals name. Keep self.color.
Yep.
And then, yeah, and then you can pretty much create a cat that way, can't you? Like if you want to do like Loki equals, I don't think I'm missing anything. Oh, a name, probably. You need the name because it needs to inside the init parentheses.
Yep. So we can definitely create a cat, and their name's gonna be Garfield, and their color will be orange. So there's one important piece missing from the constructor here, and if you look at the dog class on the right, you'll see what it is.
Um, Oh, you need the super, yeah.
Yeah,
The
exactly.
super parentheses dot init.
Yeah,
And then
exactly. And remind me again, Jacob, what are we doing here when I'm,
So you're looking at the parent, when you use super, it's pretty much like looking at the parent animal class, and you determine that based on the animal inside of the cat class parentheses. And so it knows to reference the attributes inside of animal.
yeah,
And then also in that parentheses, you'll need name, and then for species, you'll need cat in parentheses,
yeah, exactly.
or
So
not
that,
parentheses and quotation marks.
yeah,
Yeah, I think that's it. Should be.
nice, man. Awesome job, and
Thank you.
thank you. And let's go ahead and let me comment out all the dog stuff. And let's go ahead and let's print Garfield. Let's print Garfield and the special Dunder dictionary for the Garfield object to see what's in there. And just for fun, let's do Garfield dot make sound, even though it doesn't do much. But we can do let's make this an F string, and let's do self dot name says meow, just to show how we haven't created the instance attribute name in the Dunder init cat, but because we call the Dunder init of its parent class animal, and we set that instance attribute name here, our Garfield object will have that name attribute. And we see these two print statements are from creating Daryl the dog, which on line 55, which I didn't comment out, calling this constructor over here, calling it as well for Garfield. I could put the arguments in the print statement if that would be helpful to see how like name and species are passed. And in fact, it certainly won't hurt. And actually, this is a really good debugging strategy. Like again, sort of tracing the flow of data through your program. Like if I had a problem with my animal class and my animal class Dunder init, I would probably add this print statement as a sanity check to make sure that the data that is getting passed into name and species is indeed what I think it is. Right, because this is really nice to see these print statements and see this flow of data. So we can see that the super calls the Dunder init of the parent class, passes in the arguments that we pass to the Dunder init here of dog and cat of the child classes. We see here when we print Garfield, this Dunder repper that lives on the parent class gets called. Garfield makes a sound, and let's have Garfield eat as well, just for fun. And .eat note is an instance method on the parent class, which our child class has as well. What questions do folks have, and what might be good to go over? Owen, yes, sir.
How would you properly go about, so let's, instead of having a make sound and bark function in each of
Yeah.
those, have a make sound in the animal, and then make it, if it's a cat, would you just have an if statement, if cat, or if dog, or if else statement over in the actual parent class? Let me rephrase it. Instead of a make
Yeah.
sound and a bark, you just put a make sound function in the animal class.
Yeah,
And depending on the species, that's what makes it either print woof or print meow.
yeah,
How would you go about that?
great question. This is actually getting a bit into polymorphism, which we'll talk more about in part 2 of the lecture, but we can do a bit of a preview here. So what Owen is saying is an excellent point, which is instead of having make sound here for the cat and then bark here for the dog, wouldn't it be nice if our method names were consistent for all of our animals? Just make sound, and the we call make sound, and the dog goes woof and the cat goes meow. And wouldn't it make sense to have that make sound instance method live on our parent animal class, because we want all of our animals to be able to make a sound? So how would we do this? So there's basically, but still have, you know, the cat go meow and the dog bark. There's basically 2 ways to do this. One is we might have to pass an argument in. And maybe what I'll do is add a default argument like this. And I need to add it as an attribute. It would help if I remembered that step. And then the same way that we hard coded the species, we could hard code the sound in. For the dog, because I have a default argument here, I don't have to hard code it in. I could leave it empty, but let's put one in here anyway. And so now let's have Daryl make a sound. Daryl and Garfield should both be able to make sounds. And Garfield says meow. There we go. Daryl says bark. So that's one way to do it. With polymorphism, we'll see another way that does something called method overriding, but I want to get into that later. And this is a perfectly reasonable way to do it. Like, this is a good pattern to follow. And that's kind of the nice thing about with the parent class and the parent class Thunder init. You know, I only have to hard code it in once for each class, and then every time I make a cat, they'll go meow. Do folks have questions or things that you might want to review around this addition we made of shifting the make sound method over to the parent class, and adding this sound attribute to the parent class? Cool. And this is a good pattern to see. There are other ways to do it as well, but this is a good pattern. We're on the hour, so why don't we take a 10-minute break? There's a little more that I do want to cover before the before we switch to work time mode with multiple inheritance. So I think after the break we'll spend, I think probably the work time will have to be cut a bit to maybe 30 to 40 minutes. I do apologize about that, but I want to make sure that we cover stuff at the right pace. Just to recap, we've seen how, and let me go ahead and kind of, there's a lot of commented stuff out here for the dog, but for the cat, we've seen how you set a parent class here when you define it. And in the dunder init method for our child class, we use this special super function to call the dunder init method of the parent. And then the child inherits all the attributes of the parent. And what this gets us and the reason this is useful as our programs get bigger is this gets us, let me just shift back to VS Code here. code reusability. Consistency, right? Every animal now has a make sound method. Every animal has a name. Modularity. I can have my cat class do something special that only cats do. Right? Cats don't actually clean the litter box, but they're very tidy. And so I can still have cats have a color. Dogs don't, animals don't. I can still have custom behavior and custom attributes and methods on my child classes. So let's take 10, and when we reconvene, we'll see how to do multiple inheritance, and then we'll switch gears and get some hands-on coding time. Sound good, folks? Awesome. Thank you, everyone, and see you all in 10 minutes. All right. So we've been talking about and learning about inheritance, what it is, how to use it. We'll talk later about when not to use it. We've seen the super to get the parent class. Sometimes this is called the base class. And we've seen using super dunder init to call the init method, the dunder init method of the parent class. And we've seen it with a cat. And let's just take a quick refresher here. And we see here our cat Garfield. We call super init that calls this. And then our child class gets access to all of the attributes and methods on the parent class. What we're going to talk about now is multiple inheritance, where maybe cat inherits from two different classes. And to sort of warm up, let me ask you all a quick question. If I have this print statement here on line 68 in the dunder init method of the cat that I'm pointing to with my pointer, and then over here in its parent animal class, we have this print statement in the dunder init method of animal. When I create Garfield, which one of those print statements will we see first? The one here
one
on
in
line
cat.
68? Sorry?
The one right there in cat, because it's before you call super dot init.
Yeah, I think so as well. Oh, let me get rid of Daryl the dog. That's why we're seeing that extra. Let's try that one more time. Yeah, I think you hit the nail on the head there. Right? So it's important to remember, I know that inheritance and super feels a little magical. It's not. The Python runtime is still doing all this stuff in order. Right? And if I put the print statement over here, we'll see this one happen first. Right? And this is important because what if in my code, for some reason, in the dunder init, I want to do you know, print, making, let's make this an F string. Making a self.species named self.name that makes a sound self.sound. What if I want to do something with stuff that happens in the constructor of the parent here in this constructor, in this dunder init of my child? Well, that works just fine. But if I put this print statement up here before we call the parent super init, what do we think is going to happen?
It's gonna throw an error.
Yeah, exactly. Because self is a placeholder variable for our Garfield object. Remember our cat object? And we haven't added name, species, or color to the object yet. That happens here in the dunder init here when we do self.name equals name and so on and so forth. Now I know, over here we could do just name, and that's, the argument passed into the dunder init method. This is more to illustrate a point. You won't often have to do this, but sometimes you will have to make sure that stuff happens in the parent dunder init method first. So in general, when you're doing inheritance, you just always want to do the super dunder init first thing in your child, so it's done and out of the way and you don't have to think about it. And I just want to pause and check in and see if folks have any questions there. Okay, cool. And this is a warm up to multiple inheritance. So let me start writing some code for multiple inheritance, but I want you all to keep in the back of your heads this fact that like the order that the parent dunder init happens matters, and it's not magic. It's just sort of depends on how the code is written, because in just a minute we're going to see the same thing with multiple inheritance. And let me go ahead and open up the file for multiple inheritance, and let me go ahead and split it. And what we're going to do is for multiple inheritance, we're going to do mother, father, and child. So let's make a class named mother, and I don't need the split yet. So, and mother and father are going to be the two parent classes or base classes of our child class. And mother is going to have a dunder init method, and it's not going to do a lot. And let's put a print statement here so we know when it's happening, because as we saw that can matter, and this will be useful. And we're just going to set a first name, and I'm just using this is actually this bit of the curriculum was written by a former instructor, Benjamin, who's pretty great, and these are his parents, I believe, and his name is in here as well. Again, I don't encourage you guys to copy paste. It actually is really easy to make typos when copy pasting, and I think learning the things and getting it under your fingers is important. In the interest of time, I'm doing a little copying and pasting right now. So these are going to be our parent classes, mother and father, and then we're going to have a child class. And the child is going to inherit from mother and father. And let's put a print statement here, and this will just be child dunder init, so we know when this is happening. And let's set the child's first name to Benjamin. And I think that's all we're going to do for the moment. maybe what I'll do actually is let's make a dunder repr method here on the child. And this will return the first name and the last name that's going to get inherited from the parent. So we've got mother, father, child over here. Now I think I am going to do a split. I think I'll just, let me just make a runner py. I think that's actually probably easier. From multiple, forgive me. I keep forgetting that Python is happier when the file names don't have the dash, they have the underscore. With multiple inheritance, import mother, father, child. And I suppose we might as well let the child create their own first name. Then let's print Ben out and see what we see. So right now, we're not calling super at all. So let's see what this looks like when we run this code. And in fact, we get an error because last name doesn't exist on the child class. Because it hasn't been created because we never called the dunder init on either of these parent methods. So let's call super. Let's use super to call dunder init. Now the question here is, which parent class dunder init gets called? And the answer is both. Excuse me, the answer is not both. It's just mother. Forgive me. But if I change this order and I do father, mother, it's the father that gets called. So this is a limitation of super with Python multiple inheritance. And it just looks at the order that we declare it. And there are a couple workarounds to this. To be honest, in some ways, and let me just make sure I have my notes right here. Mother in it, father in it. Yeah, excuse me. So this actually gets a little tricky. To be honest, if you want to call both constructors with multiple inheritance, I know before I was saying not to hard code stuff. In some ways, this might be the easiest. Super by itself, we can see only calls the first constructor. There is a way to have super call both that I'll show in just a minute. But at this point, because we have to be specific about which ones we do or don't want called anyway, in some ways, you know, this starts to make more sense for multiple inheritance. And I can have it happen in whatever order I want, and I don't have to worry about the order that I wrote it in here. And let's see what my error is. Oh, mother missing. I think I actually have to pass in self. And there we go. So multiple inheritance, you're not going to do it very often. You're not going to do it very often. I don't think it's even on the assessment. A powerful tool, but it can make things complicated very fast. Note that the order that these dunder init methods get called in matters. Right now, the child's name is Ben Cohen because the father dunder init gets called second. And so last name just gets overridden with Cohen. And if we flip this around, the last name is going to change. Right? Just a moment ago, this was Ben Walensky or Ben Cohen, but now it's Walensky. If I flip these around, it changes, right? So that order matters. And I just want to pause and check in and see what questions folks have around the basic mechanics of multiple inheritance, or any follow-up questions like when to use it, when not, whatever's on your minds. How are we feeling on like a scale of like 10 to 20, where like 10 is I want to go back in time, and 20 is like I'm ready to write classes that like have like 5 levels of multiple inheritance. We had
It's
like
like a
like a
15.
20. I'm like a 20.
18.
Yeah, I got parent, child, and grandparents down, so we good.
love it. Love it. And thank you for the feedback, guys, because especially over Zoom, I have the grid open so I can see everyone's faces, but it's hard to tell even with that. So that's why the feedback is really useful. And James, yes, sir. I see you have a question.
I was just noticing, and I tested this out too in the runner PY. You imported mother father, but because of the way the class inheritance works, you don't actually need to import those in the runner PY, at least at the moment. I'm assuming you might want to keep them there for other purposes. I was just curious about that.
That is an excellent point. And in fact, that I should have touched on that. So that was an error on my part. So yeah, thank you so much for mentioning that, because this is actually really useful, folks. What James just said here, you hit the nail on the head, James. I just need to import child. I'm not using mother and father. I import child, and then when Python imports it, it sees that child depends on mother and father, and it does the job of importing those as well. In fact, I think, let's see if this works. I don't think that will work. That might be stretching a bridge too far. Yeah, this is a bit more that I want to get into. But you can see the child class object has all these special things, and one is this thunder thing called base, and down here we're printing multiple inheritance father. If I flip this around, it's going to say mother. So I can't quite directly access the mother and father classes themselves from the child. I'm sure there's a way to do it, but I don't know it off the top of my head. But that's an excellent point, James. We just need to import child here. And in fact, let me just get rid of that. What other questions do folks have or things that people are curious about? Cool. So the last thing I just want to show you guys is and I want to make sure I get this right, because to be honest, I always get a little confused with this part of super, and I actually don't recommend doing it this way. But we can use super to call both dunder and init methods. I think I'm not gonna lie. I actually I rarely do this, and I don't do it a lot. And I think, let's see. The super method does a lot of stuff with multiple inheritance, but the truth is you're not going to need a ton of multiple inheritance in this course. Oh, and I need to pass in self. Super argument one must be type, not child. So this is, yeah, I think I'm gonna pause here, folks, because to be honest, I am not 100% on the behavior of super here. The reality is we're not going to do a ton of multiple inheritance. If you are, you're better off doing it this way, because it, like, the way you use super, it interacts with the order that these are declared, and it just gets more complicated, and this is simple and explicit. So this is what I would recommend. I'll try and follow up with a breakdown later, but the short version is if you're doing multiple inheritance, just hard code the order that you want to call the parent class dunder init methods in. So that's part one. I know we're a little tight on time for work time. Let me show you guys the assignment for and check in to see if you guys want some work time. I think we could probably do 30 minutes and not lose what we need to talk about composition and inheritance, or if you guys want to just keep rolling. So we've covered a lot of ground. Inheritance was the big one, and multiple inheritance. Part two, we're going to talk about polymorphism. Composition is just a different way of doing things. Inheritance was really the big concept for today, but there's some important design principles we'll talk about. The assignment for part one is building a zoo with some zoo animals. And we want you to create a base class. This is just another way of saying a parent class. You'll hear both. Named animal, and we want it to have some attributes. And then we want you to inherit. And we want you to inherit and make a mammal class, and a bird class, and a reptile class. And then in fact, we want you to do a little multiple inheritance that inherits from mammal even more. And we didn't see this, but the method is exactly the same as what we've been doing. For instance, if I have a class grandchild that inherits from child, and the grandchild's name, they get to choose their own name. Let's make this a first name. And we can call super dunder init the same way we did before to activate the child class that will inherit from mother and father. And so let's go ahead and import grandchild. And I can't remember my big biblical names. Jacob, I'm just picking this because it's vaguely biblical. And Jacob is a
Very Old
grandchild.
Testament.
Yeah, Old Testament. So we're gonna run into an error or two here, I believe, and maybe something unexpected, but we can see what happens. So first off, actually, let's debug this because this is good. So remember, when you're looking at errors, you either want to look at the top or the bottom. The top here, line 9, tells me the line of code that triggered the error. This second line here digs deeper into what's called a stack trace, and it says, all right, well, this line of code on line 9 was executed, but then here on line 27 in the other file, this is where we had the problem. This is the source of the error, right? You go top to bottom to trace down. And the error is a type error, child under init missing one required positional argument first name. So can someone break down for me what's causing this error and how do I fix it? Gary, yes, sir. Oh, sorry,
Go ahead, Jacob. Go ahead, Jacob.
Mine's a
Jacob,
guess. I'm just guessing,
So-
but does it have anything to do with super having to be above line 26? Like, does it have to be the first thing inside of that?
It doesn't have to be no, though we will
Okay.
come back to that.
Okay.
In init, do you need to have self so that it can actually refer to what it is?
So self, I don't think we need. I know on lines 15 and 16, I'm passing in self. I always get a little confused by this, to be honest, because if we open up inheritance and we see when we do super init with the cat and the dog, if I scroll all the way down to find my dog, I didn't need to pass in self in here. This is a little bit of the weirdness. When we use super, we don't have to pass in self. I think when we hard code the parent name like this, we do have to pass in self.
Yeah, so we just missing the mother and father as parameters in the super.
Correct.
In it.
Correct. Exactly. The parent class here is child. Its dunder init method expects first name as an argument, and I forgot to pass in first name as an argument. And so then we see that working. Now, Jacob, you raise an excellent point. Let's see what happens if we do this. Oh, I actually would have expected. Oh, I see. Yeah. Okay. Forgive me, folks. So this works great. And actually, let me check in to see if folks have a question around this, because this is, I think, the core thing with multiple levels of inheritance is the way we've created the grandchild here and called super. So let me just check in and see if folks have any questions. So to throw a little bit of a wrinkle in here, what I'm wondering is in the child, if I take line 19 and put it first, does this first name, so first name comes from the dunder init for grandchild, right? Gets sent to line 25. It's set here, then it's passed into the super. Then it goes to the child constructor where it's set here again, which is fine because they're both the same. But then we call the dunder inits for mother and father. And I'm wondering if first name from mother and then father will override the child's first name, if you all see what I'm saying. So let's run this and see what we get. And indeed, we lost the first name, right? So rule of thumb, like two levels of inheritance, right? Grandchild inherits from child, that's level 1, inherits from mother and father, that's level 2. 2 levels of inheritance is a lot. You usually want to, if possible, avoid 2. Sometimes if you want to do it, more than 2, you're just asking for trouble right now. And it's probably a sign that you can redesign the code. The deep levels of inheritance can get confusing very, very quickly. Because, right, depending on where I put this here, it can change stuff. So we do want this here. So it's just something to be mindful of, because inheritance is powerful because the child gets all these behaviors of the parents and the grandchild gets all the behaviors of the child and the parents, but it becomes complex because if I change, like, you know, the mother, if I change something here, it could affect everything that inherits from it. So I think this is a good pausing point. I just wanted to demonstrate a multiple inheritance example since it's in the problem. What do you all want to do? I think we can take 20 minutes if you want to start coding on this. I know that's not the full hour. Or we could take a break and continue the lecture and we can probably wrap up a bit early. Do you all have a preference?
Continue the lecture and break out early.
Yes, second
Yeah.
option.
Second act,
Second
finish.
option.
Yeah. Now that we're in it, we might as well just be in it to win it. Sounds good. Let's see, we took a break, it's 10:45. How do y'all feel? You want to keep rolling or take like a short break and pick it back up?
I'm good with anything, whatever anybody else wants. I'm along for the ride.
Yeah. Let's
Sounds like we good to keep on trucking.
let's go. Let's roll. I'm a fan. I love it. Okay, perfect. Yeah, this zoo animals is a good assignment. Definitely start here today. As you can see, it'll leverage a lot of the things that we've been doing. And I think you guys will find once you start writing the code that a lot of it is straightforward. Honestly, I think getters and setters, because they use decorators and class attributes and class methods and static methods, are more confusing than inheritance. I think those things in some ways are more complex. All right, so let's keep on rolling. So we've been learning a lot about inheritance, and we've seen a bit of multiple inheritance. Let's talk about when to use it, when not to use it. And let me pull up our README real quick. We're going to talk about composition versus inheritance. And we're going to talk about polymorphism with inherited methods. So I think we'll start actually first talking about composition, and then we'll start talking about inheritance, or polymorphism rather. So composition. There's two kind of ways to design stuff. We've seen inheritance. We're about to see composition. What is the difference between those things? Inheritance is for a relationship. Composition is for a has a relationship. A dog is a mammal, right? So in some ways, to be honest, child and parent is better for composition, which we'll see, because a child has parents. Or in the example that we're going to see, a car has wheels. Right? Or like a square is a rectangle. If we were making inheritance maybe for shapes, or like a rectangle is a shape. So we've seen inheritance. It's very powerful. The truth is, a lot of the time, composition is actually the better tool. It's more flexible, it's simpler, and we don't have to worry about if someone changes, like my grandparent level class, if it messes up my code. So let's see what composition looks like, and we're going to use the car example. We're going to build a car, and my car is going to have an engine, and my car is going to have wheels. So I'm going to make some separate classes. I'm going to make an engine class. I'm going to make a wheel class. And I'm going to make a car class. And we're not going to use inheritance, but we're going to mix these together. And these classes are going to be dirt simple because they're for example purposes. I'm not even going to write dunder init methods for most of these. The engine can start. The wheel can rotate. And the car is going to have an engine and wheels. So I do want to do a dunder init method for our car. And for composition, we could give these dunder init methods. In fact, let's give the wheel a dunder init method just for fun. Self, and let's call this wheel position, right? And this is and let's say like front left, front right, rear left, rear right. And it'll just sort of be a string. And then this can become an F string that says self, wheel position, wheel rotating, just to make life a little more interesting. And our car class will be pretty simple. The car needs an engine, and it needs 4 wheels. So the engine, I'm just gonna instantiate an engine object, an instance of the engine class, and assign it to an instance attribute on my car. So now if, I've got a car, and in fact, let's write a repr method for the car. And I think what this will do, will return an F string. I don't even know what this would do, to be honest. For now, let's just have it return self.dict. I think that would be kind of interesting. And let's just see what our car looks like right now. And it would help if I actually ran the file. And return non-string type, because so this type error string return non-string type, dunder repr and dunder string have to return strings. I forgot that what I want to do here is wrap that special object attribute dictionary in a string. And so now we see it, it's not very interesting, right? The engine doesn't have a lot of attributes. Let's give the engine something just for fun. Maybe a type, and the default type will be gas, right? Maybe there's like gas, diesel, electric, and so on. And let me give my engine a dunder repr method so that it can print something out. And it's just going to return type. So already we can see composition in action. The engine class's job is to know about itself, about the engine. Over here, the dunder repr method for the car, its job is just to talk about the car. Right? I could even give the engine a status if it started or stopped. Let's always have the engine status. Let's do is started equal false. And here we'll set is started equal to true. And we can make a stop method. And then over here, and I think I'll do a split now so we can see more of the code. So the engine is up here. But down here, well, let's work with the car. And let's just say engine status. We can do self.engine. Is started. Engine, let's just call it engine running. And so now I can do Prius.engine .start and start the engine of my car. So this is composition. We're not inheriting an engine. It's like puzzle pieces, right? We put them together. We compose. We combine different things to compose our program. So this is, I think, a good checking in point. I want to see what questions people have, what might be good to go over, and what's on people's minds. I heard a hand go up, but I'm not seeing it in the grid. Ryan, yes, sir.
So I guess I'm wondering the best way that, depending on if you made like a new instance of a car, and obviously like different kinds of cars have different engines, how you would change that within the initializer for car to not just reference like
Yeah.
the engine class itself. So would you make, I guess, like another instance of an engine up in the engine class, and then how would you reference that in your, when you initialize a new car to have that specific instance of an engine, if that makes sense?
Makes perfect sense. Great question. And we have options. I think the simplest and most straightforward way is when we create a car, we need to decide what type the engine will be. And I'm going to default this to gas, so I don't have to type as much. But a Prius is electric. So engine type electric. and it looks like I forgot to do what you were saying, which was over here, pass in the engine type as the argument when we construct the instance of the engine object inside the Thunder init for car. And
Adam,
then
when you get when you
Yes,
get a
what's up?
chance, Adam, can you hit Alt Z so I can see the rest of the code on 48? You just hit Alt Z,
Oh,
or you can slide over.
oh, I see what you're saying. Thank you. Like so?
Yes, sir. Thank you.
Yeah, thank you for letting me know. Sorry about that. And let me give us a little more room. In fact, let's just make this full screen to buy a little. I don't know if that buys us a lot of real estate. There we go. That gives us a little more real estate. Can everyone see this okay? Awesome. Yeah, so that full screen mode, Zen mode kind of clears the clutter from VS Code as well, which is nice sometimes. And that's all on the under view appearance, and there's keyboard shortcuts that I always forget. The splits, by the way, if you just right click on a tab, there's split up, split down, split left, and split right. So that's how you make an electric car. You know, if we wanted to, we could combine inheritance and composition. Right now, I don't think the car needs, we don't even give the car like a name or anything else. So really all I need to do here is do super dunder init and just say engine type electric. And if I want to make like a diesel engine car, I could just set this to diesel. One, yes, sir.
Is there a general rule of thumb for when you would want to use inheritance over composition and vice versa?
Yeah, it sounds cheesy, but I think the best guide is if you, and this is where like you all will start discovering it's really the designing, the thinking, the planning, the understanding the problem, thinking about what I do or don't want to create that takes up as much or more time than the writing of the code. You absolutely can use both. There's more than one way to skin a cat. At the end of the day, you know, inheritance is a hammer and composition is a saw. They're all tools. But the best guide is when you're thinking about your program and like what sort of the miniature universe is that you're creating and how you want to model the things. What are the relationships between those things? Right? Like an electric car is a type of car. A diesel car is a type of car. A car has an engine. A car has wheels. I think that's honestly the best guide. Like a dog is a mammal, so we probably want to use inheritance there. I'm trying to think of another animal related example for has. A bird has wings. Yeah, I don't know if we would need a wings class, but if we were making, you know, our animal RPG game, maybe we'd have like a wing class for all sorts of flying creatures. I think this is the best starting point in terms of how to think about that. Composition is for has and inheritance is for is. In general, composition is more flexible. You can kind of see how nice it is here. Inheritance is really powerful, but should be used with care because inheritance is a little harder to undo. Does that help to answer your question a bit?
Yeah, that was perfect. Thank you.
Yeah, absolutely. And let me go ahead and add some composition here with the wheels. And then I think we can take a couple more questions and maybe build this out a bit more. And then we can do polymorphism. And actually, before I start adding wheels, I just want to check in to see if folks have questions, if there's parts of this code that would be useful to go over or dig into or discuss. And I'm just gonna go ahead. And since we made all these types, I hate writing code without testing it. So I'm gonna go ahead and test my code to make sure that it works. Let's just put, so this can now be an electric car. And let's just put an F string here that says Prius. And I need to close my F string. Let's put another F string here for the Prius. And this is just how I like to write print statements for my own readability. And we can start and stop our diesel Jetta as well. Like, let's just for fun, let's start the car. Let me make sure I have that method name right. And I do. So I'm forgetting something here, and I can tell because VS Code has start in gray when it should be in blue. What am I missing here on this line where my cursor is? Why is diesel Jetta.start not correct?
You forgot dot engine.
Yeah, exactly. Thank you. Thank you, Gary. And start, in fact, returns a string, so you might as well print it out. And then we're going to print out the status of our diesel Jetta, and let's go ahead and let's run this code. And let me, oh, perfect. We don't need to scroll this up at all. And so we see here, we have a diesel car, a Prius car, it's electric. We can start and stop our engines, and we can see composition and inheritance working together, in fact, where like if something is a sort of thing, you probably want to use inheritance. If something has something, you probably want to use composition, right? Because making a car inherit an engine class would be kind of tough. And then what do we do with wheels and other things? But an electric car is a type of car. And that's another way to think about it too. Like if you can think about categories or types, that's a sign that maybe you want to use inheritance. Like electric engine, gas engine, that could be good inheritance from an engine class. Wheels, winter tires, summer tires, racing tires, right? Something is something, or like is of a type or belongs to a type versus something has something, like a car has wheels. And in fact, let's go ahead and give our car some wheels right now. And so just to refresh, the wheels are going to have a position. I'm going to make it even simpler. The wheel position is 1, 2, 3, 4. I'm not going to worry too much about, you know, which one it represents. If we were writing, you know, a car simulator, we would have to care, but there's just the car is 4 wheels, unless it's a motorcycle. So let's go ahead and build this out. So we're going to do self.wheels. And I'm going to use, we haven't seen, I don't think we've seen this a lot, but this is called, I think it's called list comprehension. It's a Python shortcut, and I apologize that I don't remember the proper name of this. But what we're doing is we're constructing a list. This is really the same as if I did self wheels equals an empty list, and then I did for I in range 4 self wheels append wheel sub I. So this is one way to write it. And if this way feels more comfortable, I'd encourage you to write it this way. I think you should write the code the way that's easiest for you to read. You can condense that into one line like this. And this should give us an engine with 4 different wheels. And let's in fact add some information to our wheel. I think self rotating equals false. And we'll do self rotating equals true. And we should have a dunder repper for our wheel class. And it should return an F string that says wheel. And let's do the position. Rotating, self rotating. I'm going to make one minor change here. Whenever possible, you should always start a Boolean with something like is underscore. It will improve the readability of your code. And again, abstraction, encapsulation. The wheel class's job is to have the repr method that prints out information about the wheel. The car doesn't have to worry about it. Over here, I can just do wheel status, wheels status, self.wheels. And let's run this code now and see what this looks like. And let me scroll up a bit so we can see the car and the repr and we can see the wheel. So we can see here the power of designing lots of small classes. The smaller your class is, the better, right? The wheel class is simple. It's got a simple job, and that makes it easier to code, easier to debug, easier to compose together with other classes. If I wanted to make different categories of wheels, like a winter tire, and do inheritance, I could do it that way. I don't have to use inheritance. I could always do, like wheel type as an argument if I wanted to, and that might make more sense there. So the smaller and simpler you make stuff, the easier it is, and the more you can sort of combine these tools. So I want to check in and see what bits of code might be good here to go over again or run, and what's on people's minds. And I also want to check in on the pace because I've kind of been in a zone talking and coding for a couple minutes. How are we doing on pacing? Is this good? Did I go a little too fast? Too slow?
Much better.
Okay, awesome. Thank you. Yeah, composition honestly is where it's at. Inheritance is good. Composition is great. And I think there's a saying out there, even like prefer composition over inheritance. And if you start thinking about composition, it helps you design your programs too. I think let me do a little TL drawing, and then we'll break, and then we'll talk about polymorphism. So we've already written this code, but if we had to design a car program, I might bust out TL draw and start thinking about my car and what I need it to do. And I know it needs to have 4 wheels, 1 engine. I want a start, I want a stop, and I want to be able to turn. And as I'm thinking about, before I'm even writing code, I'm thinking of modeling my universe. What kind of program do I want to create? Well, I need to be able to start or stop the engine. And I need to be able to rotate the wheel. And I want different kinds of cars. I want diesel, electric, gas. If I wanted a motorcycle, maybe I'll throw that in there too. I'm going to put a question mark in there because that gets a little more complicated, because the motorcycle only has 2 wheels, right? So I'll come back to that later. And as I start doing this, I can start thinking about how I want to design this. And I know I'm doing this backwards. But I want to help illustrate how really the task here is thinking about the problem and how to design the problem and model the problem in the problem space, and less so the writing of the code. And so at this point, I might start thinking about my classes. You know, if this is sort of like the design statement over here in the corner, maybe now it's time for me to start building my different classes. And I'm losing a little space. So let me kind of bring these over. And I think I'm going to make one more, because we will talk about motorcycles, and I think we'll throw a motorcycle in the mix. I know I'm going to want a car class. I know I'm going to want an engine class. And I know I'm going to want a wheel class. I'm going to put motorcycle over here, maybe with a question mark. Motorcycle we'll come back to later, actually, because I want to make sure we have enough time to break and look at polymorphism. And as I'm designing this, now I might start thinking a bit more about code. Like if I've kind of decided that these are the classes I want to make, now I can start thinking maybe about my dunder init. Maybe I need to have it take a type. Maybe I need to have a start method. Maybe I need to have a stop method. You know, as I'm doing this, maybe I'm thinking, you know, like is started should be a Boolean. And then type should be, you know, a string. And this is sort of me pseudo coding this out. And it's the same process with wheels, right? If I wanted to have it, you know, do I even need a wheel position? Not really. That was kind of a flex to throw that one in, but maybe the wheel needs a position. And position, I decide is going to be an integer. If I wanted to, maybe it would be a string. And is rotated, I think, you know, is a Boolean. Truthfully, I could have is the wheel turning left or right. I didn't even add that in. You know, that could be a stretch goal. And then as I'm doing this, you know, I can see that the car, I'm probably going to want the car to have an engine and wheels. And wheels is going to be a list of wheels. And at this point, I start to see like relationships and how I might compose these things together, right? We're not inheriting, but we're composing. And if I was doing more planning, I could think about like if I want like diesel cars or not, and so on and so forth. I think I'll pause here because I'm probably belaboring the point, but I just want to show how I think like using TL draw or a piece of paper or visual tools to start thinking and planning about classes is useful. I think Francisco breaks this down really well. I'm just so used to doing so much of this in pseudocode that that's sort of the method I've gotten used to. And pseudocode works as well to kind of write it out in the comments. as you guys have seen me do at other times. So let's do folks have any questions before we break? Okay, cool. Let's take a 10-minute break and then we'll look at polymorphism and then we'll wrap up. Sound good? All right, awesome. Thank you very much, everyone, and I will see you all in 10 minutes. All right, so we did I think a pretty awesome deep dive into composition. We saw how we can create a lot of really small focused classes, each of which has one job. The engine class is just to know everything about the engine. The wheel class is just to know everything about an individual wheel. And we can compose those classes to work together. So this is another way of designing object-oriented programs instead of using inheritance. And they're both tools in the toolbox and they both work great together. And we saw here with the car class, we use composition to create an engine and add it as an instance attribute to the car, and 4 wheels that live in a list in an instance attribute for the car. And we didn't like make a start car method, but if we did, one of the things it would do is self engine start, turn left. Maybe something that would happen here is self wheels 1, rotate. Let's assume this is a front wheel drive car. I didn't think about that. That's something we could, add to the car class if we wanted to. So it would behave in different ways. We don't really have turn left and turn right, so I'll just call this turn car, because right now the wheels don't know the difference between left and right. But you can see how with composition, it gives us this really powerful pattern. And the car class doesn't have to know like all the dirty details about the wheels. It just has to know to use this rotate method that the wheel class has. And then we saw that we can combine inheritance with composition, that I can have different kinds of cars. And this touches on your point, Juan, of how do I know if I should be using inheritance versus composition? Inheritance is for more of a is-a relationship. Composition is for more of a has a relationship. Inheritance is good when you have a clear hierarchy of objects or of types. An electric car is a type of car. Right? A dog is a type of mammal, and so on. This gives you a lot of power in reusing your code, but it ties stuff tighter together, which can be challenging. For composition, it's more of a has a relationship. If we are combining several distinct and different components, like a car has an engine, like it doesn't make sense to say that like an engine belongs to a car. I think and one of the big pluses with composition is modularity, and it makes maintenance easier, right? If I want to change stuff, it becomes easier to do. Let's take a look at polymorphism. And we saw this term earlier. I touched on it. And the idea is polymorphism is the ability of different objects to respond to the same method in different ways. And everyone can see my VS Code, correct? Okay, I was pretty sure I asked that question, and for some reason I just had like a minor moment of panic. So thank you. So polymorphism sounds more complicated than it is. It's pretty straightforward. What we're also going to see is the abstract base class and abstract method that help us do this. And we're going to go back to the example of the animals with some very simple animal classes. And that doesn't belong there. And it wouldn't make sense for every animal to say meow, but that's the problem we're going to solve. We're going to have a dog class that inherits from animal. A cat class that inherits from animal. And a duck, since they all make very distinct sounds. And they all are going to inherit from animal. And right now, you know, Donald the duck, Donald can speak because Donald the duck inherits that behavior from its parent class. But Donald the duck says meow. And this is not very useful, right? You know, when you asked the question before, we saw one technique, which would be like if we made a constructor and we pass in the different sound that the animals make. Sometimes that's the right approach. Polymorphism is essentially method overriding. Different, same name, different behavior, many forms, one method, many forms. The speak method has the same name, which is great because it gives us consistency, a consistent interface. Other languages, in fact, have something called an interface that you can create that enforces the methods that you have on a class. And we're going to see that with abstract methods sort of in a minute. But the goal here is consistency, because this way, what I can do is I can have Donald and I can have Garfield the cat. I can have Donald the duck. I can have Garfield the cat. I can have, I'm trying to think of a dog from film Lassie. Obviously Lassie. I don't know how we got this far without thinking about Lassie. And I can have all my animals in a list. And then for each animal, I can have it speak. And it would help if I printed that out since it returns a string. So this is the advantage of a common interface, right? And when I say interface, think like controls. Like the interface to a car is the steering wheel and the gas pedal. You'll sometimes hear it called an API, or application programming interface. It's how does another programmer or another bit of code use this class? Well, the interface here is the speak method. And by making sure that every animal has that same method, that consistency of interface, we can write much more powerful code because it knows what to expect, right? If Donald the duck, you know, if it was, you know, make quack sound, and each of them had a different method name for how to speak, then our code is less consistent. It becomes harder for us to do more powerful stuff like we do here, where I'm not sure. Oh, it worked because note there's two meows. Donald and Harriet speak from animal. I forgot about that. So Donald is meowing. But the point is we want consistency. So as I said, polymorphism is a very fancy word for a very simple concept. So I just want to check in and see what questions people have, because this is a good pause point before I throw a couple more things into the mix. How are we feeling? Cool. And Gary, I'm just now seeing Clifford. Clifford the dog is a great call. We might as well. We should make Clifford too, just for fun. Yeah, Clifford is a classic. So this is sort of the why of polymorphism. And the advantage of this too is, you know, if the speak method for the duck needs to do a little extra work, because I mean, there's ducks other than Donald the duck, but Donald the duck is a bit of a complainer. So polymorphism gives us that flexibility, right? The method names stay the same, but I can have custom behavior, right? Many different shapes for the same thing, many different ways of doing the same thing. Python has something called an abstract base class. I'm not going to go too deep into it, but it lets us enforce some of this. ABC stands for abstract base class. This is part of the Python standard library, and we're importing this class called abstract base class, and we're also going to import something called abstract method. Because the reality is this default behavior here on line 10 of, hey, like if something inherits from animal, it's going to say meow, is not very useful and not very good. Like, I don't actually want the cat to pass. This is confusing that the cat, like, why is the cat special? And it's dangerous. What if I forget to do this for the dog and now the dog meows? What we really want, an abstract method is a decorator, just like the property decorator. What we really want is to enforce the interface, to enforce the rule that every class that inherits from animal has to have a speak method. And the way you do that is with an abstract method. The abstract method does nothing. Now this does nothing, but let's watch what happens when we run our code and we create these creatures and have them all speak. And I think let me do a split, and maybe I'll just drag the terminal up here. Is this easier for folks to read? Okay, cool. So I don't get any errors, but note that Donald speaks and no one else does, because this is an abstract method and it's not doing anything. Actually, I forgot one important step. We have to make the animal class an abstract base class. Let's watch what happens now when we run our code. This is what we want. We get an error. If I look at the error message, I see it's coming from line 25, which is where we create Garfield the cat. I see that it's a type error, and it's telling me can't instantiate abstract class without an implementation for abstract method speak. So that's what this decorator does. It enforces that that method has to exist. We don't want the abstract method to actually do anything. This is either going to throw an error or work, but we don't want it to do it. But now every class that inherits from animal has to have a method named speak. And we can enforce a consistent interface on all of these classes. Right, and that's the cool thing about an abstract base class and abstract methods. And I'm not sure if Python will let me do this. It does, but note that we did not see foo printed to the screen. This gets overridden. So just to reiterate, an abstract method doesn't do anything, but it enforces a rule that all these child classes have to have this method. And so now I can safely write this code down here on line 32 and 33, because I know with certainty that whenever I create an animal, it will have a method speak. So this is how we can sort of give structure to polymorphism and enforce it. And it's incredibly useful. And I just want to pause and check in and see if people have any questions. How are we feeling about the abstract method and the abstract base class on a scale of like 50 to 100, where like 100 is, you know, like I'm ready to go to Mars, and 50 is like I want to go dig a hole and stick my head in it like an ostrich?
Adam, respectfully, your scale is getting out of hand. All right, we went from 1 to 10, 10 to 20, now 50 to 100.
100 to 1,000.
I know.
No, I'm just
No, I love
yeah,
it.
it's good though. I think this was a good example to explain it, and the abstract just made it so that it enforces everything, and you did pretty good at explaining it. So
It's really
thanks.
good. I always had a trouble understanding abstract methods like that because I've looked at stuff before. I'm like, what's the point of it? You know, if it doesn't do anything. But
Yeah.
that was a really good explanation.
Yeah, awesome. Yeah, you all want to see one more example? Okay, and then I think we can call it. And this one I think is especially good because it's a better fit for the abstract method use case. Like animal speak is nice, but if we start talking about shapes, like rectangles and triangles, I think it's really useful. So let's have a rectangle. Let's have a circle. So, and let's throw a triangle in the mix. So let's design an interface for all of our shapes. As you guys can probably guess, as you folks can probably guess, these are all going to inherit from the shape class. And this is a good example of where inheritance is a good fit. A rectangle is a shape. All shapes have an area, right? All geometric shapes have an area. So I know that I want to have a method that I can call for any shape to get its area. But the formula is different for different kinds of shapes. So this is where polymorphism and the abstract method and the abstract base class is your friend. And by the way, the other thing that happens when you create an abstract base class is you can't just like instantiate an instance of it anymore. You can't make objects from it. Type error, can't instantiate abstract class shape without an implementation for method area. Even if we could fix that error, we don't want to. The purpose of using this abstract base class, this helper class, to provide a standard way for creating an abstract base class with inheritance is we don't want to directly ever create a shape. That's why it's called an abstract base class. It's a class that's meant to be used as the base or parent for others, and it's abstract because we never directly instantiated ourselves. Does that make sense? More or less, thumbs up. Yeah, so I think you guys can see where this is going. We're about to create a bunch of areas. And so for our rectangle, we need to have self with height. And as I'm doing this, does someone maybe want to walk me through like making the area formula for this guy? Well, at this point, it's pretty straightforward, right? We would do it the same way we would normally. We've done all the fancy stuff with the abstract base class already. And that's really all I have to do. And then for my circle, same deal. A circle has, what is it, a radius? And if I can spell radius correctly, we'll get a radius. If I can spell radius correctly there, we'll get a radius. Circle area formula is, what is it, like pi r squared, right?
Yeah, pi times radius squared.
Yeah. 3.14159 times. Sorry?
Yeah, no, that's right.
Yeah. And I think that will do the squaring. So this is actually a great example of something that's a good class attribute. I don't know, as I design my drawing program without all the classes and shapes, maybe later I don't want pi to live on the circle class, you know, the way it does right now, where I can do, you know, print circle.pi. But I clearly should have pi written as a variable somewhere in my code once and only once, and it's never going to change. So for now, a class attribute is not the worst spot to put it, so that other code can use it if it needs to. And it's totally fine for me to do it this way, and it makes my code a bit more readable. And then for a triangle, triangles honestly get a little trickier because we need to think about, like, you need, what is it, the base and the height? What is the area formula for triangle?
It's 1/2 or 0.5 times base time height. So you just
thank
need,
you.
yeah, self dot base, self dot height, and then 0.5 times base and height.
Awesome, thank you, Debbie. Yeah, I think like in a previous class, I got into like, we could inherit and we could have like an isosceles triangle be like a child of the triangle class, and it's cool, but it got a little complicated. But triangles are actually, I think, a good one to play with. Or class methods, possibly, for creating an isosceles triangle. But that's a little out of scope. And so then we want to return self.base times self.height times, I'm going to put the 0 there to help for readability more than anything. We don't need it, but this way, if without it, it makes me nervous just seeing the 0.5 like it's going to get deleted. So Now, our abstract base class shape, and if I can just exit the Python REPL here. And it looks like I do have an error, unsupported operand type for that float and int. I'm actually going to quickly call on our friend ChatGPT, see what I did wrong. If anyone knows, let me know, but I think this is the quickest way. Python square.
I think it's star for Python.
Ah,
Yeah, it's star.
thank you. Yeah, I was thinking JavaScript. And that first print statement is just our class attribute being printed out. And then the second one is the area of our circle. So again, to recap, our shape is now an abstract base class. We never actually create an instance of a shape, but we can inherit it in all these other classes, and it will make sure and enforce that they all have a method named area. And that's the power of the abstract base class and the abstract method and of polymorphism. Because now if I'm writing a drawing program to draw stuff anywhere I need to, I can have, you know, shape area. The same way we saw with the animals, right? And then we'll just have a square that's a rectangle of 4 and 4. And I can have for a shape in a list of shapes. And print its area. Like say, if I need to draw all the shapes on the screen or get the area of all the shapes on the screen. So that is really the last thing for us to cover. We did not end up finishing early, but I think we got a lot of good ground covered and went into some good depth digging into things. And then this is sort of setting you guys up to do the assignments this afternoon, which I think will be really good ones. Inheritance is a lot of fun. Composition is a lot of fun. It makes everything more powerful. I think the best advice I can give is try to keep classes small. There's more than one way to skin a cat, so don't over worry about should I do it this way or that way. Sometimes the best way is just to do it, and then you can always change it later. And in general, look for opportunities to use composition. Do folks have any questions or are curious about anything before we wrap up? Okay, awesome. Let me quickly show you guys the assignments that we have for today and go over the afternoon schedule, and then we will break. So for these assignments, we already took a look at the Zoo Manager. For polymorphism, we have a Boggle game, which I think will be a lot of fun. And you'll want to spend a little time with TL Draw or a piece of paper, starting to think about what classes you want and what methods should be on those classes. And you'll want to make a Boggle board to do various things. I don't think we have tests for this one. We have tests for most of the other ones. We have a continuation of the app users assignment from yesterday. The user class is now going to become a base class, like we saw with the abstract base class, and you'll make premium users and free users. There's not a lot of skeleton code here. My recommendation is start this from scratch. It is harder to refactor and modify existing code than it seems. It's easy to get lost in the sauce when you're doing that. I recommend trying to start from scratch. You can reuse the assignment. I would try starting from scratch. I would even maybe have my other code like split screen to look at as a guide. I do that all the time, but I think starting from scratch might be a good idea. And then we have some assigned reading from this book, Practical Object-Oriented Design in Ruby. This is like the classic book on object-oriented programming. It is in a different language, Ruby. Ruby is extremely readable and similar to Python. It's just that this is maybe the best book out there in terms of being an introduction to object-oriented programming. And like a previous job I was at, like this was the book they recommended. And it's extremely good. And so we want you to take a look at page 208, which is floating around in here. Let's see. Let's see where it's hiding. 208 to 212. So I think, I'm not gonna lie, I think the page numbers are wrong in here. Maybe I have a different PDF. I'll follow up to confirm these, but you absolutely don't skip reading this book. If you take a look, like a lot from the lesson is pulled from here. And there's just a lot in here that's really, really good fundamentals. Like deciding what belongs in a class, organizing code for easy changes, creating classes that have a single responsibility. And there's a great example of bicycles and gears that's very similar to what we saw. And then with what we talked about with polymorphism, you see talked about here in interfaces. And so this book is sort of worth its weight in gold. And I know it's easy to skip the reading, but I would encourage you not to. And you can see here, this is a little bit more formal, but there's a couple different ways to sort of like draw diagrams to design programs. Do folks have any questions about the assignments? Okay, awesome. Thank you, everyone. Let me go ahead and stop the recording.